let's start with this problem. Find the integral from 0 to infinity of e to the minus x sine of 2x dx. All right, seems like a innocent enough question. Now, when you see an exponential multiplying by either a sine or a cosine, I'm not going to say trig, I'm going to be very specific here, sine or cosine, what are you going to do? What's going to happen in this case? Integration by parts. So this is very classic integration by parts. And this is a really special case. What happens in this particular case? Now, you have to do it twice. This is the kind of problem where integration by parts is so nice, you do it twice. And then you somehow say, after doing it twice, I kind of get back to the original, but not quite. And then you move things around. Okay, so when you see this, you have two options. So one option is you can do the indefinite integral and work that out first. And then move to the definite integral. So this has its pros. In some sense, it's a little bit easier to follow. Now, option 2 is you just go for it. Just do it. Is that the slogan?
Just do it, yes.
It's like Nike, just do it. So let's go with option 2. But if you're not comfortable with that, just say, all right, I'm not comfortable. I'll stick with option 1, where I go through and say, do the indefinite integral. So indefinite integral, remember, that means drop the bounds. Go through, figure out the integral. And then you say, okay, once I have that, then you can say, I can now do the evaluation. All right. So we have to decide integration by parts. What's the part we integrate? What's the part we differentiate? When it's exponential times sine or cosine, which part should we integrate? And which one should we differentiate? Or does it not really matter? It doesn't matter. It doesn't matter. Now, people have their own biases. I'll probably say, let's make the trig part the u, the part we differentiate, and we'll make the e to the minus x our dv, the part that we're going to integrate. I think it's a little bit easier to integrate the exponential function than to integrate the trig functions. Trig functions can get a little bit weird because you have to keep track of plus minuses. Okay, so doing a little bit of work here. The antiderivative of e to the minus x is what? So if you antiderivative are the integral of e to some constant x, what do? It's e to the constant x, and then you have to account for the constant. Now, what means you divide by the constant? Now, it turns out dividing by -1 is the same thing as multiplying by -1. So just make sure you remember. E to the constant x, to find the integral, it's e to the constant x divided by that constant. What is du? 2 cosine 2x. Beautiful. And we'll throw in a dx on the end. Okay, so we now have, at this point, this is equal to the, well, all right. We should be ever so cautious. Because this is an improper integral, we should have mentioned that. Why? Why should we mention that it's improper? Well, oftentimes they'll go out of their way. But if it's clearly improper, and this is, there's an infinity involved, on the exam, they will be looking for us to write the word limit somewhere. So let's make sure we get our points. So it's an improper integral, so limit as b goes to infinity of integral 0 to b e to the minus x sine 2x dx. this is the problem with just doing it. Whereas if you have an indefinite integral, you don't have to worry about writing the limits yet. You don't have to worry about writing limits at the end. All right, so limit as b goes to infinity. And now we have our uv minus e to the minus x sine of 2x. Evaluate that from 0 to b. And then minus the integral from 0 to b of v du. So there's a minus e to the minus x 2 cosine 2x dx. All right. Well, we can break this limit up because limits break up nicely over addition if the individual pieces work. So I suspect they will. So this is limit as b goes to infinity. And now let's do our quick evaluation. We can plug in b, e to the minus b sine of 2b. What happens when you plug in 0? You get 0. Sine of 0 is 0. Okay, that's from this part. Now here, we'll say, well, minus, minus, and a 2. So that's a plus 2. So plus limit b goes to infinity of 2 integral 0 to b e to the minus x cosine 2x dx. Okay. Let's take a moment and think about this piece. What happens to this as b goes to infinity? And why? As b heads to infinity, what happens to the expression e to the negative b times sine of 2b? Gets really small. Now, what part gets small? E to the negative b. What about the sine of 2b? It's bounded. So you have something that's small times something which is bounded. So what's going to happen to it? It's going to get small. This goes to 0. Now, if we wanted to throw a word in to 100% convince people that we knew what we were doing, what's the magic word to explain this? And I know you're trying to be like, wow, man, Steve's trying to squeeze out every last drop of Calc 1 knowledge that I have. But I know you know this. I know you've heard of this. So think back when you were first learning about limits. You said, okay, I know we talked about these ideas. And just like, come on, stretch your brain, squeeze really hard, squeeze it. Oh, what? Come on, you can remember this. What's the idea? Why is this justified? It's by the squeeze principle. Which says, if you have something bounded times something going to 0, the whole thing goes to 0. Because you can basically say, this limit, I can bound it above by e to the negative b. I can bound it below by negative e to the negative b. Those both go to 0. So this thing which is in between them must also go to 0. All right. All right. Okay, well, good. That means this part is 0, so now we've got down to this problem. Okay. Now the question. Which part should be our u, and which part should be our dv? Same as before. Once you commit, you've got to be consistent. If you change your mind, bad things happen. All right, so that says the trig part was our u, the exponential part was our dv. Well, the antiderivative of e to the minus x is still negative e to the minus x. Antiderivative of cosine 2x, so that's our v. So the derivative of cosine 2x is minus 2 sine 2x dx. All right. Well, what do we have? This becomes the limit. B goes to infinity. Don't forget about the 2. We're going to put the 2 in pieces. So we have 2 uv. So 2, and then there's a minus 2 e to the minus x cosine 2x. Evaluate from 0 to b. And then we have this 2, minus 2, integral 0 to b, minus e to the minus x, minus 2 sine of 2x dx. All right. Whew. Okay. Well, we can minus makes a plus. And let's see what we have here. So this is our limit. B goes to infinity. When we plug in here, we get minus 2 e to the minus b cosine 2b. Subtract, when we plug in 0, what do we have? We get e to the 0 and cosine of 0, which are 1. So minus a minus 2 makes a plus 2. And then we have here minus 4 integral 0 to b, because the 4 can come out, e to the minus x sine 2x dx. All right, let's talk about these pieces. What happens to this, e to the minus b cosine 2b, as we go b to infinity? B goes off to infinity. This does what? Goes to 0. Why? Still the same principle, that e to the minus b is going to 0 and the cosine is being bounded. And if you're like panicking, like, oh, do I have to remember squeeze? We haven't talked about it before, so no. But it's nice to remember things. It's like all these things come back together. What does this happen to? What does 2 do? It stays as 2. And how about here? Well, this is minus 4 integral 0 to infinity e to the minus x sine of 2x dx. Okay, so we get 2 minus 4 integral 0 to infinity e to the minus x sine 2x. Now, why do I do all this? We started here. We're now up to here. What's the next step? Yeah, we can add this to both sides so that we get 5 integral 0 to infinity e to the minus x sine of 2x dx equals 2. And then what? Divide by 5. So there's our answer, 2/5. Yes? All right. So if you didn't like this, remember there was a different way to do it, which is just says do the indefinite integral first and then evaluate with the definite part. But if you do have bounds, the idea of like working with the bounds and then rearranging still applies. This adding infinity just makes it a little bit more obnoxious, but that's okay. All right. Any questions? There might be some questions here. Yes?
Okay, so you set it equal to each other, but how you
These things are equal.
how you get 5?
There's 4 here. How many of them are there here? So I'm going to add 4 over to this side, because these are the same, but this has a factor of 4. 1 plus 4 makes 5. So that's where the 5 is coming from.
So just
Do you have questions, or should I do a different problem? I'm also willing to answer questions. We have about 10 minutes left. We could probably make some progress in another one.
just had questions about like the partial fractions of like how the bottom bracket splits up to a, b, x, c, x, b.
We did partial fractions last time, so we should probably do something a little different right now. Okay. So here's a problem. Find the integral from 0 to 2 of 1 over the square root of 2x minus x squared. All right, good. Whew. Does this integral have any issues? Is this an improper integral, or are we good to go? It's what? Why do you say it's improper? I don't see any infinity here. 0 and 2, those are far from infinity. Oh my gosh. At which part? Well, where's the 0 happening in the denominator? What do you mean by all of it? It's always 0? So we do have issues. So at x equals 0 and x equals 2, we have a divide by 0, which means we have asymptotes. So if you were to plot this, I don't know exactly what it looks like, but it does something like this. So here's 0 and here's 2. So we have problems, my friend. Problems right here at both the ends. Okay. So how do we start this problem? What's the right technique for this? 1 over the square root of 2x minus x squared. If you saw that integral, what technique would you go for? And why would you do that? You can do this integral. You have the technology. Trig sub. Okay, what sort of clues you to think maybe trig sub may be involved? Square root, right? Yeah. On this test, if you see something that's square rootish, you think trig sub. All right, now, are we ready to make our trig sub, and why not? When you're looking for trig sub, what are you looking for? You're looking for number squared, function squared. Okay, x squared, great, that's function squared, but 2x is not number squared. So that's not the right form for us to do a trig sub. So what do we need to do? Complete the square. Complete the square. All right, so 2x minus x squared, let's just do this. When I do complete the square, I always want what's in front of the square term to be 1. We don't currently have that. We have a minus. So I'm going to do something fancy called factor a minus out. So it's minus x squared minus 2x. And then I'll give myself plenty of space here, as if I'm anticipating something to happen. Now I have a 1 in front of the x squared. Life is good. I'm ready to complete the square. I come in front of my x, and I say, I see a minus 2. And I say, okay, what do we do with this minus 2? What's the procedure? Divide by 2 gets us minus 1, and then square it. So we want to add 1. And doing that will give us an x minus 1 squared. So we've completed the square. But the problem is, we've changed the expression. So we have to compensate. So how do you compensate for adding 1? Subtract 1. I'm going to do it right away. And now we can distribute the minus 2. This is the same as minus 1 makes a plus 1 minus x minus 1 squared. Okay, so that tells us that our original integral becomes the integral 0 to 2, 1 over the square root 1 minus x minus 1 squared. Okay, Now, we're in the right form. This looks like a squared minus u squared, where a is 1 and u is x minus 1. What's the substitution to make for a squared minus u squared? It's the sine. U equals a sine theta. So for us, u is x minus 1, a is 1. So x minus 1 equals sine theta. Take the derivative of both sides. What's dx? Cosine theta. So dx is cosine theta d theta. What happens to the square root of 1 minus x minus 1 squared? Becomes the square root of 1 minus sine squared, which becomes cosine. All right, a few other things. Let's talk about our bounds. So we'll do that in a different color here. So here we have 0. So x equals 0. That tells us that we have x minus 1 equals, 0 minus 1 equals sine theta. So sine of theta equals negative 1. When does sine equal negative 1? Sine theta is negative 1. What angle does that? Unit circle. Is sine the x's or the y's? Y's. So which angle is that? 3 pi over 2 or negative pi over 2. Usually we limit ourselves from negative pi over 2 to pi over 2. Okay, at x equals 1. Well, not 1, 2.